So yeah, I have a question on resonance, using tuning fork, We have the tuning fork resonance experiment. Now, here's a question. In a resonance tube experiment, a sounding tuning fork was brought close to an open end of a tube, and water was gradually let out of it. If the first and the second loud sounds were heard, when the water level were 20 centimeter and 30 centimeter respectively, below the open end, calculate 1. The wavelength of the sound neglecting the end correction. 2. Frequency of the tuning fork used. Now, here's a question on resonance. Now, what they were trying to tell you here is this: when you place a tuning fork on the open end of a tube, with water, and you gradually let the water out, what will happen? You will hear a first loud sound. Then, as you continue let the water out, you will hear what? Second loud sound. Now, that loud sound, what they're trying to tell you there is resonance. Now, what is resonance? It is the point whereby, the frequency of the tuning fork, the frequency of vibration of the tuning fork equals to the frequency of vibration of the what? Air column. The natural frequency of the vibration of the air column. That is what we call what? Resonance. So the frequency of the tuning fork and that of the air column is what? Equal. Now, we want to solve a question related to that. Now, I will show you some pictures, Now, we have a question like this. The solution. We all need to understand that wavelength all over 2 will be equals to the difference between the length of the what? The column, the tube. Now, which simply means L2, what is our L2? L2 is what? L2 is what? 30 cm. L1 is what? The 20 watt cm. So L2 is the point where we add the first what? The second resonance, whereas L1 is the point where we add the what? The first resonance. Now, the difference between these two will be equals to half of what? Wavelength. So which simply means the wavelength, which is lambda, will be what? 2 L2 minus what? L1. Do you get it now? Now, you were asked to calculate the wavelength. This is the formula you will use. Now, to calculate the wavelength will be 2. What is L2? L2 is what? 30 minus what? 20. So, we should be equal to 2, open bracket, 30 minus 20 will give you what? 10. So, that will give you what? 20 watt centimeter. Now, the second question is the frequency of the tuning fork. We want to know the frequency of the tuning fork. We want to know the frequency of the tuning fork. That's the next thing we want to calculate, the frequency of the tuning fork. Now, you were given the speed of sound in air, which is V is 340 meter per second. Then, the frequency of the tuning fork is unknown. Then we've already calculated the wavelength, which is what? 20 cm. So approximately in what? In meter, it will be what? 0.2 watt meters, because you will divide this by 100 for you to convert it to watt meter. Now, V equals to what? F lambda. So using frequency as the subject of formula, frequency will now be V all over what? Wavelength. V is what? Velocity, which is what? 340 all over 0.2. So 340 divided by 0.2, what do you have? Can you quickly check it with your calculator there? That's 3,700 watt hertz. This is the frequency of the tuning fork use. However, there are many things we do with tuning fork. Many things we do in tuning fork, In medicine, we use tuning fork for Weber and Reining's test. Rein's test. Now, what do we use this for? We use it to check if someone has hearing defect, hearing defect. And the common tuning fork used has frequency of what? 512 hertz. Do you get it now? So the common tuning fork used has a frequency of what? 512 hertz. But the common tuning fork we use in the lab, in physics lab, is what? Is 256 hertz. That's the common tuning fork you will see almost everywhere. However, the one we use for Weber's test and Rayleigh's test is what? 512 is to check what? Conduction. Maybe someone has what? Was a neural what? Defect, related to was it hearing, you get? So what do? You vibrate the tuning fork and you place it maybe on the forehead, just to see if the person can hear any vibration. If the person can hear any some vibration, then definitely it is structural. It is not what? It is not a neural defect. That is, the hearing defect is not pertaining to what? To nerve. However, it's pertaining to the structures in the ear. So that's what we want to talk. That's what we use tuning fork for in the hospital for Weber and what? Rayleigh's test. So this is where we stop today. Yeah, thank you.